Hi, my name is Joseph Haw, and this is my CSCI E63 Big Data Analytics final project on Amazon Web Services machine learning platform. Machine learning is a data analysis concept that automates the building of analytical models by using pattern recognition to find insights or make predictions with historical data sets. Amazon Web Services offers a machine learning platform based on the tools originally developed by Amazon and its core retail business to make business decisions and predictions regarding customer behavior and preferences. The Amazon service can evaluate training data sets, analyze the data, and then find the best patterns and algorithms for analysis. These patterns and algorithms are then used to build a recipe that can be used on its own or customized to best fit the user's data needs. Amazon's machine learning platform comes with a number of key benefits. The service will automatically evaluate the data and pick the best algorithm for what you are looking to accomplish. This includes binary and multi-class classifications and regression analysis. The service is fully managed and scalable. The end user does not need to deal with configuration issues or the internal workflow as the data moves through the machine learning tool. This allows for large or small machine learning jobs to be set up quickly with low technical overhead. The service integrates easily with other Amazon Web Service applications, allowing for easy integration with model results and adding predictive capabilities to other Amazon-based applications and services. There's robust API access in many common languages, and almost all of the machine learning functionality can be accessed through the API. You also pay for what you use. Their only initial costs are running the machine time for training and evaluating the models, and then per prediction cost while the model is actually being used to make predictions. There are also built-in evaluation tools and visualizations. These allow you to kind of gauge how well the model is performing with your data. The machine learning platform accepts a number of data formats, primarily data that's in CSV files that are stored on Amazon's S3 data storage platform, or data that's stored in the AWS Redshift platform, which is Amazon's data warehousing service. For this project, I chose to analyze a set of crime incident data, and kind of my primary goal for the project was to analyze the data and classify the various reported incidents into a number of different categories. I obtained this data from a site called Kaggle, which is an online data science community, and they host a number of contests and data sets for people to kind of run experiments with. The data set I used is, like I said, a collection of incident reports published by the City of San Francisco as part of their police department crime incident reporting system. The data typically ranges from 2003 to 2015. From that site, I pulled their training data set, and that contained right around 800,000 records. There are a number of fields in the data set, including time information, category, and this is actually the attribute that I was going to train the machine learning system to be able to predict. Descriptions of the incident, day of the week that the incident occurred, the San Francisco Police Department district, how the incident was resolved. So, was a person arrested, booked, etc. And then approximate address using longitude and latitude information. As we get started using the tool, one of the first things that we have to do is prepare the data. We need to add the data to the S3 platform, and it has to be a properly formatted CSV file. Typically, machine learning works best when we have very clean data. So this means that we need to get rid of records that might, include incomplete data, malformed data, or have some other sort of formatting issue that might, cause the machine learning tool to kind of misread or misinterpret the data. As commonly said, garbage in, garbage out. So we want to, in order to get the cleanest data out, we want to make sure that we're feeding it the cleanest kind of historical data. So for my project, the kind of the first task was to do a couple of things. I wanted to split out the timestamp data to kind of extract out month, year, and hour of day values, because I wanted to use these as categorical attributes, as part of the machine learning process. I wanted to remove records that contained malformed dates, and some records that were just kind of incomplete. And I also removed the longitude and latitude information. I think this would have been helpful as part of the analysis, but it would have required me to convert the data into some sort of kind of distance clustering, and I just didn't approach that in this part of the project. Once we have the data prepared and added to S3, we can begin the machine learning process on Amazon. And the first step of that process is going to be data source creation. This process includes a number of steps. We're going to tell AWS where we can find the data source. We're going to provide it a name. Amazon will then verify that the file is formatted correctly. It will spit back if the CSV is malformed or it's in some unacceptable format. We'll then review the attributes. These are going to be the columns in the CSV. We're going to make sure that we provide names, and we're going to identify the data type. The various data types that are accepted are numerical data, categorical data, binary data, or just kind of blocks of text. We'll then select a target variable for prediction. So this is going to be the attribute that we're looking to teach the system to learn to predict. And in our case here, we're going to teach the system how to identify the category field. After the data source has been created, we're going to move on to model creation. So a machine learning model is just an algorithm used to perform some function on a set of data that is built using historical data. Common use might be just categorization, so identifying the category, like a grouping, how documents relate in that way. We're doing kind of a regression analysis on more numerical data. The Amazon machine learning service takes a set of training data as an input and then finds the best model to achieve the task at hand. The data set is split into training and testing sets. The testing portion of the data is reserved for the evaluation phase. This split is usually 70-30, and Amazon takes care of making that split for you. In order to set up the machine learning model, we must provide the following. So we have to a verified data source, which we covered previously. We have to select whether we want to let Amazon build a recommended model or if we want to provide a customized recipe. We need to add any necessary data transformations. So this might be, teaching the model that if we come across an address, splitting that address into the requisite parts, city, zip, state, etc. We need to select the size of the model. So larger models can accommodate more data scenarios and patterns that are found. We also need to select the number of model runs. So more runs may be able to find more patterns, etc. We also want to select shuffle settings. Shuffling helps prevent unintentional patterns found in the natural order of the data being analyzed. You may not want to use this if your data sequence is important, but in a scenario here where we just have a kind of a large data set, we definitely want to shuffle because we don't want to teach any non-important patterns to the system. And we also want to we want to determine if Amazon should do some data regularization. This will just kind of help accommodate, for instances, where too many patterns are found, and that might lead to overfitting. So once we have our model designed and created, the model will go ahead and train on the data. And this process can take anywhere from say half an hour to a couple of hours, depending on the size of the training set. Once that's done, the system will go ahead and start evaluating the data. So this will take that testing set that we had earlier and then see how that performs in the model that was built using the training data. Depending on the type of model, so whether we're doing a binary regression or multi-class categorization, a particular evaluation technique will be used. In the case of this data where we're doing a multi-class categorization, there'll be two primary evaluation techniques used by Amazon. The first is generating an F-score value. And so this is just kind of a weighted average calculated using precision and recall values. So precision is the ratio, is a measure of the ratio of correct observations, and then recall is a measure of the ratio of correct predictions. And these scores range from 0 to 1. The higher the number, the better predicted accuracy. Using our data set, you can see that we achieved an average F1 score of about 1. The next evaluation tool that Amazon provides is called the confusion matrix. So this compares results between the true and predicted values. So the chart displays a table showing the number of percentages of correct and incorrect predictions for each of the major classes. Smaller categories are going to be grouped together just for kind of readability purposes, but you can also download the full data set that would be used to create this. And like I said, the chart compares the observed and predicted class versus the known true class to see how well the model performs. So once we have the model's been created and we're satisfied with the results, we can begin doing using the model for predictions. Amazon machine learning allows for 2 prediction types. So we can do real-time predictions. So this is basically where the model is just available, and we could have an application that uses the API to use the model as an endpoint to just pull whenever necessary to request a prediction based on a set of circumstances. There are additional costs involved in using the real-time prediction because you have to have a level of reserved capacity, and obviously Amazon expects you to pay for that. The second type of predictions that you can make on models are called batch predictions. So this is where we feed the model a large set of data, so many number of records all at once. It takes a little bit longer to run, and it can handle batches up to 100 million records at a time. And these can be generated from the AWS console or through the API. And these come at about a fixed cost of about in sets of 1,000 predictions, and the current cost is about 10 cents per 1,000 predictions. And like I said, batch predictions can be requested through the console or via one of the APIs. So for the technical implementation of my project, I wrote a script that basically will allow a user to take a data set in S3 and then have it run through a pre-built model to return predictions. The predictions will then be saved back in S3. I wrote the script in Python using Amazon's Bodo 3 AWS API. So basically what the application does is it asks the user for the kind of data source, the initial data source location. It assigns that data source a data ID, and it verifies whether the data source is formatted correctly. And it also uses a pre-built schema, and this is the same schema that was used in the model creation. So that way it checks to make sure that the data that we're feeding in to request batch predictions on matches the attributes that we have in our model data. So the script will go ahead and build a client session with AWS, and from there we can start making API requests on that, and we send that through the API to AWS, and that's returned, and the results are then returned to us in JSON format. So once we have the data source built, it goes ahead and waits until it's verified and AWS says this data source is good. Then once that's confirmed, then we'll go ahead and send a request to have batch predictions made. And this script will just go ahead and feed in the batch ID and the batch name that were used previously, and the location where the data is found and where the results will be saved to on S3. And this just runs here from the terminal, and as you can see, it provides status updates as it goes along based on the progress of the kind of data load into the model, and then as it takes time for the predictions to be generated. Once the predictions are generated, they're saved back to S3 in CSV format with predictions for each observation. The predictions are presented as probabilities for each potential category. So it will say, here's the description of the event, which robbery on the street, strong arm. And then it will basically go down all of the known categories that it learned during the training phase and say, this is the probability that this particular incident falls into this category. The category with the highest probability is the best possible prediction for that observation for the given field. And here's just kind of a visualization of a test run of some data that I ran through the script, where we can see the probabilities are plotted for each of the categories for each of these 5 incidents. So thank you for checking out my presentation on Amazon's machine learning platform. I hope you enjoyed it, and thank you for your time.